So, a quick true or false to get us going today. People are more likely to have a heart attack in the morning than at any other time of the day. What do you reckon, true or false? Well, actually, it's true. The reason for it, well, it's to do with blood clotting. Okay, blood clotting, like a lot of other functions in the body, is controlled by the time of day. It's part of what we call a circadian rhythm. And this is as we get into the end of our biological psychology topic. This is where we're hitting now. We're hitting biorhythms when we look at these things there. And so blood clotting is actually um, connected with heart attacks, obviously causing heart attacks by causing blood clots. And we can see there's a increased incidence heart attacks in the mornings by comparison to other points in the day. And the reason for that is that you're more likely to develop a blood clot in the morning than you are at other times of the day. Not a massive one, but it's a thing. And also when we look then at doctors and medication, when they choose to do certain types of surgery or that sort of stuff, they may schedule someone either deliberately in the morning or deliberately later in the day because of those clotting factors. Okay, so this is actually still psychology. We're looking at biological rhythms on this, and we're going to be looking at some examples today. It's going to get covered 2 sessions on this. We're going to look at both the different types of rhythms. So we've got infraradian, circadian, and ultraradian. And then we're also going to be looking and talking about exogenous zeitgebers and circadian and circadian rhythms, as well as endogenous pacemakers and circadian rhythms. There's some different terms here, and it'd be lovely if they were all separate and easy, just not on those things there. But they are kind of overlapping quite a lot, which can make this area a little bit tricky sometimes to get our head around. But we're going to do our best. We're going to work our way around it. We're going to try and be clear on these there. So let's start off with the key terms for this area. So first of all, we have biological rhythm. So it's any distinctive pattern of change in the body that goes in cycles. So i.e. it goes around and around and around. It happens again and again and again. So when we look at circadian rhythm, it's connected with the Latin circa diem, about day. So that's about 24 hours. So it's a rhythm that happens pretty much once every day. Then we have our ultraradian rhythms. Now, these are rhythms that may occur many times a day. So I like to think of them as things you're ultra keen on, or are ultra important. As such, we do it many times a day. So we have dinner, we have lunch, we have breakfast, we eat multiple times a day. The reason is it's an ultraradian rhythm. When we move on to infraradian rhythms, now these are rhythms that take longer than 24 hours to occur. So they take longer than a day to happen. That's quite a different thing. So we've got this one which takes longer than a day, one which takes a day, and one which happens multiple times a day. Okay, ultraradian, multiple. Infraradian, less than one. Circadian, once a day. So we also then have factors that affect biological rhythms, and they broadly get pushed into two categories, two types of terms. So we have endogenous pacemakers, and they are basically our body's internal mechanism for tracking when certain things should happen. So when a baby is very young, they have a very, very quick digestive cycle. You may be listening to this while I'm on paternity leave, in which case you'll probably hear me moaning, like many parents do, about the fact that babies' digestion cycle is within like 2 hours, and they're hungry again. Every 2 hours, they're hungry again. We got feeding like 12 times a day. Seriously, who designed that system? Terrible design. Anyway, so we can see that endogenous pacemakers, for adults, we've got bigger digestive systems, and we can go for long periods of time without that, but we still get hungry more than once a day. However, that endogenous pacemaker of becoming hungry, that is to do with our sugar levels, it's to do with our ghrelin levels and those sort of things there, and that's really important. When we look at Ozempic, and when we look at the new sort of weight loss drugs and all that sort of stuff, we see that they are affecting the biological rhythms and affecting things like ghrelin and our susceptibility to it and the influence of it, and to whether we experience hunger or not. Moving on to look at exogenous zeitgebers, we see these are anything which is an external factor which affects our body clock or our body systems on those things there. So, for instance, if you're feeling shattered and you come in to school and you have a coffee in order to pick you up and help you go forward, then you are bringing in that artificial energy. You're bringing in those things there, which are going to be blocking our normal sleep-wake cycle. Now, that's going to be an exogenous cycle. But also, if you got blinds which don't perfectly cover the edge of your windows, and blackout curtains not really effective, then it's likely that the changes in light are going to affect when you wake up massively. So that's the factor to also look at. We also have a whole range of other ones, but basically, exogenous cycle is anything external from us that might affect it. Okay, so what I'd like you to do then is I'd like you to look at the blue box and look at which of these are suitable examples of each rhythm, be it circadian, ultradian, infradian, endogenous pacemaker, exogenous zeitgeber. I'm going to flag up though, there might be some that come under a couple. Okay, so go through these and have a look and see what you think those examples are. Are they a circadian rhythm, ultradian, infradian, endogenous pacemaker, exogenous zeitgeber? Please have a go now. Okay, let's have a look at some answers. Hopefully you've thought those through. So this first one, the menstrual cycle. Menstrual cycle, of course, is going to take longer than 24 hours. That'd be horrible if we went through it every 24 hours. However, I will point out the male one does take technically about 24 hours generally, although there is also other research showing that men's testosterone levels do vary over time, so they can get days when they're more moody and more more happy, etc., on different days. So we can actually see the stuff in the testosterone cycle as well. But looking at the menstrual cycle, we see that is infradian. So it takes, and I'm going to say on average, 28 days. We're going to talk about this loads more later, but we'll move on for now. So sleep-wake cycle. Hopefully you were thinking, well, it's circadian rhythm for us, for human, adults. However, technically for babies, it's an ultradian rhythm because they have it many times. They often have a nap multiple times on there. So for adults, we generally have a circadian rhythm of sleep-wake cycle, which is only once a day. But as babies, we actually technically have it multiple times. Ultradian. Bad design, I know. Anyway, hunger digestion cycle. Well, that is an ultradian rhythm, as this happens multiple times a day. Think of it. We have reasons. We have these established breaks and things there. We tend to eat and all those things there. So we have lunch, we have break, we have breakfast, we have tea, we have dinner, we have all those other things there. If you're a hobbit, you have second breakfast. But yeah, and a second breakfast for hobbits makes sense because basically they're smaller people, therefore their digestive system is going to contain less. Therefore, hobbits will need to eat more regular meals. Interesting. We also do see Chinese people have a culture in which they eat more regularly but they eat much smaller meals and they have smaller bodies. I think there's a design connection there, guys. Anyway, moving on. Let's look at body temperature cycle. Again, that's going to be an example of a circadian rhythm as it varies throughout the day and is predictable in pattern. But we could have things such as a hot sunny day or a cold winter day. And that would be an example of a what? Yeah, that would be an exogenous Zeitgeber that would be affecting us. Um, and while I picked up on menstrual cycle, the sleep-wake cycle, the hunger-digestion cycle, and the body temperature cycle, all of those also fall into the classification of, yep, an endogenous pacemaker. There's something in our body that makes that happen on those things, and that's an endogenous pacemaker. So endogenous pacemaker is for all of those four initially, as well as being the examples of particular rhythms. And then when we look at dawn and dusk, we see dawn and dusk are particularly with the increase in light and increase in temperature that affects our body, affects the way in which we wake, and etc. Those things there, and as such, they are factors which affect our sleeping patterns, and therefore they are exogenous Zeitkibbles. So let's get into it. Let's get some more depth here. So let's talk about biological rhythms. So all animals and plants are subject to biological rhythms. If you ever have the spice saffron and use that, one of the most expensive things in the world, is the stamen from crocus, which have to be picked in the very early hours of dawn. If they're picked too late, they open up um, at dawn as part of the biorhythm of the plant. And if they are then exposed for too long, all the fragrance is lost, and the actual quality of the spice massively declines. So it's a very intensive process, and it's actually worth out to 14. It's because the plant has a biological rhythm which is connected with the temperature, which so there's an endogenous light giver, which affects it and goes through there. So yeah, plants have them, animals have them on those. Okay, so we often refer to it in layman's speech as the body clock. And so the circadian rhythm is the one which tells the body when we need to sleep. It regulates also many other physical processes, such as our body temperature, and that as well. So internal body temperature is actually affected by environmental cues, which I'll give you some advice in a moment about shoe shopping. So please do pay attention to that one. It's an important one. We're going to look at three examples. We're going to look at the sleep-wake cycle, blood clotting, and the temperature cycle. So let's have a look at the next one. Right, so this is an example of this circadian rhythm that is the sleep-wake cycle. So first of all, we're going to start off by waking up. Yo, wake up. Okay, so we're awake and we start using energy. Okay, so as energy starts to be used, we also have melatonin start to build up. And this leads to us feeling tired and sleepy and yeah, so we got to rest. As such, melatonin then starts to be broken down and disposed of. Now, what happens if we don't want to go to sleep then? Well, we have a nice cup of tea or coffee or Monster, or any other sort of high caffeine drink, and the caffeine blocks the receptor sites for melatonin, and as such, it stops us from feeling tired and makes us feel happy and awake. Doesn't actually give us any more energy, and unless there's energy being given in, say, a form of sugar that accompanying that drink, but it just blocks our melatonin, so we don't feel tired, but we're actually shattered. So yeah, that's why they work, but also why they're problematic. Anyway, normally when we are asleep, we start to get melatonin being broken down there, like other neurochemicals, and disposed of. It's one of the reasons why we do need sleep on a regular basis. After 36 hours of consciousness, people start to often exhibit abnormal symptoms and thought processes are confused and delayed and problematic. After 72 hours, a lot of people are experiencing hallucinations and psychotic symptoms due to the chronic buildup of neurological neurochemicals in the brain. So we don't want that. So this sleep-wake cycle is super important. Okay. We can also see it being plotted there. They plot the level of melatonin as it goes through the day. It's got a nice little one circadian cycle for melatonin sleep connected with sleep. So we've got the awake, so sleep awake being indicated there, and we can see that basically goes on this never-ending pattern, which just repeats and repeats and repeats. And particularly as light falls, and particularly the exposure to blue light falls, we then have this greater build-up in melatonin. And that leads us to sleep on those. And it keeps us asleep until it's time to wake up, where initially our brain then starts to break down that melatonin levels. The melatonin levels drop back down, and we wake back up. We're awake for most of the day, and then as we start to get to that tired, at the end of the day, we start to get melatonin levels creep up. So we get our sleep. We go to sleep. Yeah. Okay. So that's the sleep-wake cycle. Let's look now at a different one. This is the core body temperature. Now, I will flag this up for being slightly problematic. This is normally done based upon data collected from men. I know, I hear you cry, oh, but that has androcentric bias. Aren't they guilty here of alpha bias on this, of treating women as if they're men, or androcentric bias, where they're treating women as if they're men in a negative way, they're making judgmental statements about women? Yes, yes, they are. Well done if you spotted this straight off the bat. Women, because they have a menstrual cycle, the menstrual cycle affects the sleep patterns, sleep-wake patterns, and also their body temperature cycle. And as such, the menstrual cycle is seen as a extraneous variable. And so in order to then conduct the research without that being a factor, they then go for the male-only participants. But technically, the majority of the population actually have a menstrual cycle. On average, there's 52 to 53% of the population being female. And so we are actually establishing a norm based upon a minority population, which is problematic. So yeah, this is an area which is interesting, but also problematic. What this graph is showing us is, again, that when we're sleeping, when we look at sort of 12 a.m. till about 6 a.m., we see the lowest body temperature. We're not moving much on there. And actually, we see the body temperature, it's not massively low. This one is given in Fahrenheit, annoyingly. But it is a study showing us that there is variation in the body temperature, which leads me to a really important point about shoes. Okay, when you're up and about, you're doing things all day, as your body temperature rises throughout the day, your feet gradually expand. Also, as you're up and standing on your feet a lot more, your feet gradually expand throughout the day. So it means that there's 2 times of the day when you really don't want to buy shoes, i.e., first thing in the morning and late on in the afternoon. You want to kind of do it around 2 to 3 on there. You don't want to be buying shoes at like 7, 8 p.m. You don't want to be buying them at like 8 or 9 a.m. You want to be buying them about 2 to 3. And the reason for that is your feet are going to be on their average amount of expenditure, so that your feet are not going to be too loose in your shoes at the start of the day, and they're not going to be too squashed in your shoes at the end of the day. But if you buy them at the end of the day, then at the start, they're going to be too loose. They're going to give you blisters. If you buy them at the start of the day, they're going to be too tight. They're going to feel that pressure, and that's going to cause damage to your feet all day. So, top tip: buy shoes between 2 and 3 p.m. Although, folks, I will flag this up. That does not mean you can go and do it in the school day. You're going to have to do that either when you don't have lessons, or better still, on a weekend or holiday. Okay, but yeah, life shopping advice there. For you from your podiatrist, stroke psychology teacher. We also, as I say, we do have big issues with this on in the forms of bias, which I did sort of flag up earlier. That simply put, the use of males to carry out this data because of the extraneous variable of menstrual cycle is massively problematic. Although they're trying to gain more reliable data, what they are by nature of it doing is limiting the applicability of their data to purely men. But as we know, these things are seldom only applied to the original group and are expanded outside of that. And as such, this is problematic. They should do research not just on women, but also on men. Moving forward, let's talk about these. So, as a variety of this was there, so you've got about a core body temperature. So it fluctuates. It's not massive. Okay, our body is still trying to maintain homeostasis. There's a GCSE science term. Anyone knows what it means? Yep, hopefully you said about trying to keep it the same sort of thing. But even within that, it does vary. So I've got it there in the English ones. So between 37.1 and 36.7 in centigrade. Annoyingly, the other one was an American study, and as such, it reports in Fahrenheit. And I haven't gone through and converted the data over because I just haven't. I probably should, but I haven't. Anyway, so other examples of the human circadian rhythm include heart rate, metabolism. There is loads of people, loads of personal fitness gurus, loads of trainers, loads of dietitians, loads of medical specialists who will talk to you about metabolism and variations in the day and what and when you should eat. And when you shouldn't eat, and what type of things you should eat at this point. And it's all based around this understanding of metabolism and how you metabolize at different times of day, doing different sports, all those things there. But what we do see is that there's a similar pattern to the core body temperature, in which it may not seem surprising that our metabolism, our heart rate, our breathing tend to be also all connected with our core body temperature. We're very much seeing very similar patterns of activity there. The only sort of exception to this is people who work shifts. So particularly people who are required to sleep through the day and therefore be more active at night time. So it seems that, obviously their level of activity is going to change that. But what we actually see is that underlying circadian rhythms, such as body temperature, metabolism, resting heart rate, still tend to be set to be in the day. They still should be a diurnal rhythm based upon the day. And that is problematic because it's going to cause us real problems for people on shifts and all those sorts of things. I'll talk about that a little bit more later. Anyway, so let's look at the hunger digestion cycle. As I said, for adults, this is a ultradian rhythm, and for children, this is even more of an ultradian rhythm. All depends on how big your digestive system is. And we see in smaller people, they tend to be hungry more often and eat smaller meals. In larger people, they tend to have larger meals and be hungry less often. But here it is. Here's the hunger digestion cycle. I could also add in ghrelin as well as insulin. I've talked about low blood sugar on this one. I've kept it as simple and straightforward as possible, but I can add in some more technical terms, which I will do as we go through. So please do annotate your slides on those. So we get hungry. Now, hunger is a drop in ghrelin, is a drop in insulin levels that's precipitated that and led to it. So that leads us to be more aware of food opportunities and those things. As we might start noticing smells or anything that, and it's all driven to make us eat. And so at some point we eat. Okay, now eating over time, when we start to process it, that increases our level of blood sugar, and because of that, our level of insulin and increases, our level of ghrelin drops, and that leads to us experiencing the sensation of satiation. When we look at the chronic obesity issues in the world, we see that nutrition that our ancestors grew up with had a high demand on the amount of calorific value and nutrition value, but also to actually process and get it and get from when you're going from berries and from roots and those things there, the processing of that actually took quite a long time. So the way in which you're eating and the way in which you're waiting for that system kind of worked. Nowadays, the problem is you can have eaten 2-3 squares of chocolate, and that will give you that blood sugar high, but you can also eat the rest of that massive bar before it hits. So you can end up feeling a bit sick and a bit, because you've overeaten, you've overtaken too much sugar, too much things there. And that's because we live in a modern world with lots of calorific and also energy rich foods available to us. So we have to be careful of that. Interesting. One of the original diet recommendations in the Victorian era was the one and drink, in which you basically would have a fork full of your meal. You would then place down your cutlery. You would then take a sip of water. You would then cut up your next piece of food. Then have the fork full. Then place down your cutlery. Then take another sip of water. Then you see, and the idea is that it just made you take longer to eat your meal. And by doing so, it meant that actually your body starts digesting sooner. And so you feel full sooner and so eat less. It's a very interesting but very simple way of regulating how much you eat in a calorie high world. Actually, could be something which, if we did it in a healthy way, please note, healthy way, could be effective. Although it would make dinner time very, very long. Anyway, so once we have a high blood sugar, our insulin goes up, our ghrelin drops down, we feel satiated, so we stop eating. As you stop eating, we're using that energy, and over time, it leads to low blood sugar and high ghrelin levels, and that makes us feel hungry, and it goes again. Okay, so let's look then at the sleep patterns. So do you have any idea what these birds are? No? Well, I bet you got the bottom one, but not the top one. Yeah, the top one is of course a lark. You probably spotted the owl. However, you probably didn't spot the lark because you may not be up with the larks. It's an old saying, up with the larks is for someone who's an early riser. And the lark is one of the UK songbirds, which will often be part of the dawn chorus. And so in 2000, Duffy et al., they did a study in which they looked at people's different sleep-wake cycles. And what they found was that you could separate out people into either larks or owls. Larks tend to be people who get up naturally and comfortably and happily in the morning. So I am a lark. I get up happily in the mornings on those things. I go and do those things there. My wife is an owl. So she will be grumpy in the morning. If she can sleep for a few more hours, she's much happier. And yet she will also stay up a couple of hours later than I would. This is an example of an endogenous pacemaker. and it does change throughout your life. There also does seem to be a thing where women um, tend to be more likely to be owls, while men tend to be more likely to be larks. Theory, kind of loosely being connected with it, is the idea that men need to go hunting in the early hours, and as such, that got them up and going sort of hunting in that sort of dusk, where they're more likely to be successful, and that women is supported with childcare, etc. That's based on theoretical um, speculation based upon evolution. Um, so let's then look at factors that affect these biological rhythms. Okay, so that's an important thing. There are many different things that may affect it. So, for instance, the women's menstrual cycle. If you've not been having enough nutrition, it's likely to be erratic. If you have a very high BMI or very low BMI, I know the BMI is a terrible measure. Please, I just use it briefly. It is a problematic measure based upon white European men with certain body types and certain things being made to look normal, certain musculature, etc. They use that as the ideal, and so it doesn't really work. But generally, they use the BMI, and they say that if you have very high, very low, then that might also be a reason why the menstrual cycle does or doesn't happen. Um, and that can be something that affects endogenous pacemakers here in Bollowick. But also, generally, we have those things which are part of us, but we also have other things that are outside us that might affect it. So it might be the level of light, it might be the heat, it might be the smell of cooking food that makes us hungry. There's many different factors which can affect you. Okay, now there's a guy called Michael Schieffer. His studies is an example of endogenous pacemakers being demonstrated in the absence of exogenous zykibas. So he's created what is a very artificial situation. I will have put a link to the Word document on the YouTube clip. So please do look at the full study here. But basically, Michael Schieffer, he is French, in 1962, although he's done many times since then, many others on there, but his original study took place in 1962. He was a geologist, and he basically went into a cave system in France, and he went into the cave, which, as you can see, sort of roughly I've mocked up here to try and make it understandable. He went to the point where there's no natural light, there's no natural um, heat variation, all those things there. Because he's underground, he doesn't experience any of the natural endogenous zykibas, which are normally in the environment around us. And he wanted to see what they did, what the effect was. And so basically, he had his research team. We had a connection, he had a phone in the cave, and he would call them at different times throughout the study and report back and have a conversation with them. But they would never let him know what the time was. That it was always him running it based upon his timing and what he thought it was. He didn't have a clock in there, you know, any other things there, and he was cut off for 2 months. And he didn't experience time change, temperature change, and light day, all that stuff. He found that his internal control of the circadian rhythm, his endogenous pacemaker, um, since even in the absence of external cues, he maintained a regular daily cycle of hunger, of being becoming hungry, eating, not becoming hungry, going back again, going in, but also sleeping. And he found that his sleep-wake cycle extended on average to between 24 and a half to 25-hour cycle, which shows that, in theory, based purely on our endogenous pacemakers, um, we do have roughly a particular cycle in which we need to sleep and wake. However, you have to be careful because we can get sort of crazy conspiracy theories going out of this as well. Because there will be some people who would argue that this is evidence that we're, not from this world. We weren't evolved here. We evolved on a planet where there's a slightly longer day, etc. Sorry, folks, not true. We're not aliens. The evidence is best accepted that we were evolved here. But the point is that although he had the endogenous pacemakers, and so he slept on a regular basis, it did extend, it did change. When we look at a couple more, we see Ashoff and Weaver. Now, they sent some participants into a bunker without any natural light. Access to a full military bunker was a little bit easier in those days. And all but one of the participants, their sleep cycle extended to 29 hours long, showing that actually endogenous cycles are important for keeping people's endogenous pacemakers consistent. Okay, so when we combine this with Schieffer's research, it indicates that yes, we have a natural sleep wake cycle, but that it is also affected by endogenous zeitgebers from our environment, which cause us to maintain our sleep cycle in our environment. Okay. So let's have a quick look here. Body temperature cycle and learning. So this is a meta-analysis application question. I'm going to give you some facts. I want you then to think about what this means. I want you to have a stop, have a chat, have a think on these. Okay, so I'm giving you these three pieces of information. Here's our first one. Full card. Variations throughout the day in body temperature using a story retention test where they talk people's story and ask them whether they can remember it to young children. And it was found that it was better when the internal temperature of the child was higher at 3 p.m. than it was at 9 a.m. Okay, so they remembered better towards the end of the school day than they did at the start. Interesting. Gupta, in 1991, carried out IQ tests and found that IQ test scores generally improved when a peak body temperature was being recorded at 7 p.m. rather than times in which it was lower of 9 a.m. or 2 p.m. Although I'm slightly suspicious that maybe those ones doing it at 9 a.m. maybe they were tigers, had to get up early to go to the university to do that. Who was it they're using? Probably Unisons who aren't used to getting up to those lectures in time. Or is that just me being skeptical? Anyway, Kelly in 2010 then, and there is a talk she does on TED Talks about this school day, and she showed that pushing the start time of the school day back in America was connected with driving up results. And so she did this in a school in the UK, and for a year, the only thing they really changed was this start time of the school day. They pushed it back from 8 till 9. And the results was that the students' academic results went up on average. So what do these studies mean for the school day? What changes should be made and why? Please speak to the people next to you and think, based upon the evidence and the data which we're being presented with, what recommendations would you make? Okay, so feedback to the class now then. Okay, so hopefully you've done that. Yes, of course, what we're looking for is for you to be saying that we should probably start the school day later. Give children a little bit more time in bed to rest on those things there, but also go later in the day, particularly for teenagers, will help them to have a higher core body temperature, and their ability to retain information and perform a higher level will be increased. Therefore, we'll get better test results if we have the school day starting later. So that's a great one if you want to write a letter to Mr. Wilkes about all that. I dare say there's more research out there by now, so do by all means look for more ones. If you want that extra couple of hours in bed, please do the research and send it to Mr. Wilkes. Let's see you can make change. Okay, so let's look at the evaluation points in this area. What I do is grab a textbook. I want to find these points in the textbook on the pages on endogenous Zeitgebers and endogenous pacemakers and circadian rhythms and all those. There's normally two pages around this, so you have to find the first 2 pages of that. And what I like to do is I like to find those points in the evaluation and then go through and make note of, firstly, what are they actually focused on, and secondly, work out whether it's a supportive point or whether it's a critical point from there, and make your notes in a standard way. Okay, let's have a look. Let's whiz through these then and sort of recognize what it is. Okay, so first of all, bovine support for endogenous pacemakers, shift workers, they are finding that actually they tend to have much more injuries if they're going against their biological rhythms, both in the short term, that's not great, and long term, that can be really problematic. And so it's led to industry actually changing the way they're working in order to try and work with people's biorhythms a bit more. So, for instance, most factories and those things will break for breakfast at about 6 a.m. in order to prevent the accidents that normally happen at that point. When we then look at Knudsen then goes on to also look at stress and decline of health of shift workers over a long period of time. And so that shows us that actually people who are kind of fighting against their body's natural diurnal rhythms and instead living that nocturnal life, they're going against their endogenous pacemakers, and as such they tend to suffer from ill health because of it. Again, that supports that endogenous pacemakers are kind of fixed and we can't just change them out willy-nilly. Beraldo also supports that, as it shows that theory has led to more effective use of medication. So really important, if you get medication prescribed to you, read the information. One, find out what side effects are, but also 2, find out when exactly you should be taking that medication, because at sometimes it's going to be more effective than others, and it may lead to less side effects as well. Our 4th point is actually our first critical point, where there's, simply put, case studies like Michael Schieffer, that's only one person, and individual samples. Like criticism as a small sample size is always a real problem, because we have to then question the reliability of the data that's being produced. The smaller the sample, the greater the impact of individual differences. More anomalies are going to shape the data in a powerful way, and as such it's going to lead to the data being collected from the studies being more indicative indicating rather than demonstrating. It's showing us that there might be a thing here rather than showing us that there is a thing here. We need bigger sample sizes if we are to be able to make more conclusive statements, or to be able to generalize the findings to others. These small sample sizes are problematic. Caesar also then goes on to support exogenous Zeitgebers. So using artificial light was able to shift people's rhythms on there in quite a funky little study on there from memory. And then, of course, Duffy. Duffy comes back with Larkin and Owls. It's support of endogenous pacemakers, showing that actually people do seem to have their own fixed type. There's some individual differences, and that some people remain as owls, some people go as larks on those things, but we can see it happening there. Okay, so hopefully those made sense. Let's do a quick look then at the next slide. What I'd like to do now is I'd like to log on to your Quizlet. I'd like you to go on to the biological psychology, and I'd like to have a go at test 5 on the biological rhythms. By all means, have a go at test 1, 2, 3, 4, or any others as well. If you've got a little bit of time, independent studies, brilliant. Do it, use them, make it work for you. However, for now, what I'd like to have a quick go at, if there's still time in the lesson, do that. If there's not time in the lesson, please can you now do this as homework? Okay, so a final little task then, just to finish off. What I'd like to do is I'd like you to think, what is the difference between these rhythms? I would like you to practice writing or coming up with a difference-based statement about each reasons. Okay, so working with a partner, I'd like you to create a way of helping people to remember the difference between the different ones. Drop me an email if you come up with something which you think is a really good one, and we can share it with class. And as I say, I'll give a small prize to the best idea. Because if we come up with a great idea that works for everyone, then you know what? We'll use it, and we'll use it for future years. I hope you found this interesting. It's one of those things I think affects us a lot in life generally. But please now make sure you got all the notes up to date, and we've got one more lesson in biopsychology after this. Thank you very much, folks.